Thank you for joining this lesson. We're going to handle gradients and equation of a straight line. Number 19, we are told that a straight line L1 has a gradient of negative half and passes through point P, which is negative 1, 3. Another line L2 passes through points Q and R with the given coordinates. Let us start with part A, the equation of L1. So L1 is having a gradient of negative half, as seen here, and it is passing through P, which is negative 1, 3, as indicated. Therefore, for us to express the equation of this line, we need to let another point to be xy. So that now we re-express this gradient using the gradient itself, the provided coordinate, and now the coordinate we are letting to be xy. So that we say the gradient negative half, which is here, equals to change in y out of change in x. So when we take y and we subtract the other y here, which is 3, we'll have y minus 3, as indicated here. Then now we go for change in x, whereby we will take x and we subtract the other x here, which is negative 1. Therefore, we'll have x minus 1, and the 1 is already negative, so x minus negative 1 as expressed there. So what we do next is now to have negative a half being equal to y minus 3, but now x minus followed by a minus becomes positive. Therefore, we will have x plus 1. Now we can cross multiplication, whereby 2 will go with y minus 3, and negative 1 will go with x plus 1, as shown in this step. Therefore, we have, when we open brackets, we'll have 2y minus 6, then negative x negative 1, as at that point. We can now rearrange the equation to have 2y to remain here, then equals to negative x. We had negative 1 here, so now when x 6, which is negative, comes to this side, it becomes positive. So negative 1 plus 6 will get positive 5, as indicated. Then now to have the expression in the form y equals to mx plus c, we will have to divide by 2 through, and the equation becomes y equals to negative a half plus 5 out of 2. Then part B, gradient of L2. So we need to get gradient. We can call it M2, such that again we use change in x, change in y divided by change in x. So we are having the line passing through Q and R. So we will have change in y, 5 minus negative 3, 5 minus negative 3, divided by change in x, 4 minus 1. So 4 minus 1 is shown there. So this becomes a plus, 2 negatives following one another. So 8 out of 3, which can be expressed as 2 and 2/3. So that is the gradient. Then again, the equation of L2. Now equation of L2, for us to express the equation, we'll have to let again a point xy, like in this case, whereby now we will say 8 out of 3, the gradient, equals to change in y minus, remember I'm picking a coordinate xy and one of the provided coordinates here for L2. So I prefer Q, such that we will have y minus negative 3 divided by x minus 1, as shown there. Therefore, we can cross multiply now. Remember, this becomes a negative. It's 2 negatives, so they become a positive. So 3 will go with y plus 3. 8 will go with x minus 1. So we will have this step. Then from there, we open brackets and rearrange the equation so that we have y equals to 8x minus 17, and to remain with y on this side, we divide through by 3, so that we will have 8 over 3x minus 17 out of 3. So that is the equation in its simplest form. Part D finally, part D here. the equation of a line passing through point S, which is 0, 5, and is perpendicular to L2. The first thing to know is that the gradients of two lines which are perpendicular to one another give a product of -1. Therefore, we pick the other gradient, which when multiplied by the gradient of L2, remember the gradient of L2 is here, 8 out of 3. Therefore, the gradient which when multiplied by 8 over 3 gives us -1 is its reciprocal with a reversed sign. So the reciprocal is 3 over 8, but now with a reversed sign, a negative. Now we are going to express the equation of this other line which passes through S, and the gradient now is already identified, such that the two gradients multiplied will give a -1. Therefore, now we shall have -3 over 8 equals to change in y. So again, we are picking another point xy, such that change in y will be y minus 5. Remember, coordinates of S are 0, 5. So y minus 5, x minus 0. X minus 0 just becomes x. We cross multiply again. 8 goes with y minus 5. -3 goes with x. So at this point we can divide, after rearranging here, through by 8, so that the equation becomes y equals to -3 out of 8x plus 5. Finally, the equation of a line through R parallel to L1. For two parallel lines, they have similar gradients or the same gradient. Therefore, a line parallel to L1, because we were told from the instructions that the gradient of L1 is -1/2, then this gradient here will also be -1/2, such that now -1/2 equals to change in y minus 5. Remember, it is passing through R, and the coordinates of R are 4, 5. Therefore, y minus 5, x minus 4, that is the step. Then we cross multiply. 2 goes with y minus 5, -1 goes with x minus 4. So we will have, after opening brackets, then we rearrange the equation and we divide it through by 2, so that we have y equals to -1/2 plus 7. Thank you for following. Subscribe and share.